Hugh Brock. I'm going to talk about, I'm going to talk about TripleO, which is the OpenStack on OpenStack project. My talk was advertised as RHEL OSP Director, and TripleO is the basis for OSP Director, but that's not really what I'm going to talk about today. I'm just going to talk about TripleO because I like it. A little bit about me. I'm a Director of Engineering for Redhat. I've been at Redhat since 2002, believe it or not, either because I really like it or because I lack imagination. I haven't figured out which. And I am responsible for our OpenStack installation, deployment, and management tools, I and the rest of my team. Wow, my glasses are really foggy. I'm going to take these off. I think I can see you better without them. That's much better. Right, so TripleO. OpenStack on OpenStack, or as I like to call it, owls all the way down. Some of you may know this quote. It's a quote from a woman who had just seen a talk about the motion of the planets and how the Earth revolves around the sun and so on. And, well, I won't read the whole thing, but you can see at the end, she says, well, you're very clever, but really it's just turtles all the way down. The reason I like to put that up is that people tend to get a little freaked out when I tell them that we use OpenStack to deploy OpenStack in TripleO, but actually it's not quite as bad as turtles all the way down. There's really only 3 or maybe 5 owls, depending on how you want to look at it. Anyway, so what I'm going to talk about, I'm going to talk a little bit about the mission of TripleO, what we want it to do, what we think is interesting. Then if I can, I'm going to quickly go through how a basic OpenStack deployment of an application works. If you're an OpenStack user, how do you deploy an application? I'm going to do that in 6 minutes, if I can. Then I'm going to go on to talk a little bit about TripleO concepts and how we use OpenStack to deploy OpenStack. Then I'll go into some detail on how deployment works, and finally talk about what the features are that we have coming, have now, and what we have coming soon. So, the TripleO mission. What do we want to do with TripleO? We aim with TripleO to manage the entire life cycle of an OpenStack deployment. The life cycle of an OpenStack deployment involves planning. We have to plan, a deployer has to plan the network topology. They have to plan the roles and where the OpenStack services are going to go for each role. They have to plan the capacity of their cloud, even though they can change it later, but you have to start with a plan. And they have to encode the plans that they make in templates, and ideally keep those templates in source control so that when they change them later, they can see what they've done and get the results they expect. When you get down to a deployment, an operator has to do a sanity check first. TripleO provides tools to do that. They then have to deploy the hardware and the services orchestrated in steps, so we do things in the right order. They have to manage the dependencies among services. And to do sanity checks, we find you have to do as many of them as you can during the deployment, because sometimes you just don't see things that are wrong until you get midway through deployment. And again, at the end, ideally, once you've done an OpenStack deployment, you want to run Tempest on it, or you don't really know if it's working. Finally, third part of the mission of TripleO is operations. Once we have TripleO deployed, we want to be able to manage software updates, configuration changes, major upgrades, scale up computes, add new compute classes, scale down compute, scale storage up and down. These are all things that TripleO either can do or is about to be able to do. And we think they're pretty important. So, OpenStack in 6 minutes. Right. Here are some of the really important OpenStack components that go into deploying a cloud application, both either on VMs or bare metal. You could do either one. We have Nova here, we have Neutron, we have Glance, we have Ironic, and we have Heat there's obviously many more, but these are the ones that TripleO is most interested in, so I to focus on them. And I'm realizing I've left out the OpenStack Puppet modules, which we rely on heavily, but that's not typically part of an OpenStack user's deployment experience. So, how does this work? Nova provides guests to users, right? The user walks up to Nova and says, give me a VM. Nova complies. It gives them the VM in the size and shape that they expect with the network configuration that they are asking for, right? Neutron provides networking services to tenants. So you create virtual networks for VMs that connect internal networks within the VMs in an application, manage floating IPs to connect to the outside world, provider network connections, security groups, all the good stuff that Neutron does. Glance, the image management service, tells Nova where it can go to download the image that you want it to launch on the cloud. This turns out to be important, both for deploying an application and also for TripleO. I'm going to skip Ironic for a minute. You'll see where that comes in later. The most important, probably, service for deploying a multi-node application is, of course, Heat. It's an orchestration service that provides a consistent, repeatable deployment of a multi-node OpenStack application from human-readable templates. All three of those parts are very important. Now, in addition to deployment, Heat can manage updates to the configuration of a deployed stack, scale out operations on a stack, and can also add additional different kinds of machines to a stack once the stack is running. This is all very important. I'm going to take a quick pause for a second. Is it possible I could get the mic you can hold? Standing in front of this thing is making me feel like a deer in the headlights. Over there at sound. Could I get the other mic? Do you have one? No, I guess not. Okay. Sorry about that. I'm just going to stand here and look at you like this. So, that was OpenStack in 6 minutes. Now we have the TripleO concept and how that plays into a normal OpenStack deployment. Right. So the concept of TripleO is fairly simple. Seemed like a great idea a couple of years ago. Still seems like a great idea to me. The concept is, since OpenStack provides a set of tools that are designed to deploy a complex multi-node application on VMs or on bare metal, why not use those tools to deploy OpenStack? And that's what we set out to do. Right. Okay, so you're going to deploy OpenStack using OpenStack tools. Where do you start? Well, the first thing is you've got to have Nova set up, and you've got to have Nova set up so that it will deploy to bare metal rather than to VMs. Now, fortunately, we have this project called Ironic that provides an API that lets Nova do exactly that. But before Nova can do that, it's got to match bare metal flavors to hardware, so that when you tell it, I need a machine this big to be my compute node, it can pick that machine. Or alternatively, and we actually like this method better, you can tag the nodes that you have so that Nova knows, all right, I'm going to deploy my compute nodes on any of these machines that are tagged this compute flavor. So we can skip the flavor matching that way. Once Nova has all of that information, it can then use Ironic's API as a special sort of bare metal hypervisor. Neutron is the next project we're going to talk about. For a virtual deployment, Neutron creates virtual networks between machines and floating IP routes via the L3 agent out to the outside world. For a bare metal deployment, like, say, an OpenStack deployment, Neutron either creates ports and routes and tells our configuration services about them via OSNetConfig, or in a really fancy ideal world, Neutron hands out IP addresses for the various networks and then configures the switch you want to use via SDN plugins. Now, we're not quite there yet, but we have people in this room who are working on that. Glance, as in the normal OpenStack deployment, Glance holds the images that we use to make an OpenStack deployment. You upload images to Glance, it provides a URL where you can retrieve those images from, and you then pull them down and write them to the nodes that you're going to deploy to. Now we get to Ironic. Ironic provides the API that makes physical machines look to Nova and the rest of the OpenStack services as though they were a VM. Ironic will also introspect as much information as it can from running the Ironic Python agent on all of the actual nodes. So once it boots the agent the first time, it loads the IPA code onto there, runs a whole bunch of diagnostic stuff, hardware discovery, introspection stuff, sends all that information back to the Nova database. It will also run burn-in and network failure detection stuff, which is pretty neat. Finally, we get down to Heat. In this case, Heat is providing deployment orchestration for hardware nodes. It captures the hardware configuration in Heat templates. So the operator chooses which templates they want to use to deploy. Those templates describe the cloud configuration that we're going to deploy, and you can store them in source control so that you can repeat what you want to do. So that's the basic mechanism for TripleO, and you can see that it works more or less exactly the way a normal OpenStack deployment would work, only using bare metal. Again, I left out Heat's in particular for deploying OpenStack. Heat also depends on the OpenStack Puppet modules to do the actual configuration. So what we're really doing is the Heat templates are generating a bunch of HIRA data. When we boot the nodes, OS collect config runs on the nodes, pulls that metadata down from Heat, and then passes it to Puppet. And Puppet goes and does its thing and runs the configuration steps on the various nodes. So, a deployment in action. The important thing to remember with TripleO is that you actually do have two clouds. At some point, when we get to doing HA versions of TripleO, we will actually have to have three clouds. But that's a different story entirely. Anyway, right now we have two clouds. You have a deployment and management cloud, the undercloud, and a tenant-facing cloud, which is the traditional OpenStack you know and love, called the overcloud. The deployment and management cloud is your infrastructure command and control for the OpenStack that you're running. It is visible only to the cloud operator, and we call it the undercloud. Your production cloud is the cloud that your tenants will use. As I go through this, I'll be talking about the two different clouds as we kind of progress. So here's a typical TripleO deployment flow. You come in to your data center, some nice person has racked and wired your hardware for you. All of these things are ready to go. The cloud operator, who's going to do this deployment, has the bare metal control IP addresses and credentials for each of the new machines. You have to have that data to give it to Ironic, unless you're really lucky and you have some kind of fancy BMC auto discovery thing, which does exist for DRAC and ILO and the other proprietary management interfaces, but typically you just have to feed Ironic the information. The cloud operator also knows her desired network architecture. So CIDRs for all of the different networks that you're going to use to connect up the OpenStack services, which interfaces on the machines that those networks are wired to, and so on. This becomes very important in constructing the templates. So, first step, once you've got all of that information, is to pick which node is going to be your undercloud. All right? So we identify the undercloud node. Next thing you do is install it. Installing the undercloud is relatively easy. It's just a normal rel install a few extra RPMs, fill in a config file, run puppet apply, and you have an undercloud. Now, the undercloud node needs to be able to reach two different networks, the power management network for all of the nodes, and also the provisioning network. The undercloud node can provide both DHCP and iPXE over that provisioning network. Unfortunately, that makes the undercloud, which is not highly available, a single point of failure. So we actually recommend that people use a separate, their own network DHCP server on this network. Once the undercloud is provisioned, the operator can now give it the hardware details, BMC addresses, credentials, machine host names. If you want host names assigned, you can do that. Provisioning IP addresses, all of these kinds of things. And this is also a very good time to run all of the pre-deployment validations on your OpenStack so that it doesn't blow up when you go and try to install it, which you will find that it often does blow up. It's funny that way. Right, the next step is introspection. Ironic boots all of the nodes via the BMC, pixies the IPA image onto it, and runs introspection. When the introspection is done, Ironic will have a full set of facts for each machine, all the way down to everything that you can get out of DMID code, plus, if you choose to run them, lots of performance information. So we'll run stress tests on the disks, stress tests on the processors, on the memory, and return the results of that back. Actually, all that stuff doesn't go directly into the Ironic DB, it goes into Swift because it's really too big to stick in the undercloud database. Once we have all the machine facts, the operator can go ahead and start entering either manually into heat environment files or via the UI, which I will talk about in a little bit, the needed information for the deployment. So that's all the CIDRs I talked about, interfaces for the various networks. There can be 7 or 8 of them, either VLANs or physical networks, and get all of that stuff ready to go. You also have to name the interfaces in the templates. You can name them just by boot order, NIC 1, 2, 3, and 4 if your machines are consistent, or you can use interface name, or in the most extreme case, you can actually name the NICs that belong to each network via MAC address, which is sort of painful, but sometimes you have to do it that way. Now, in this example deployment, this is going to be a real simple deployment. It's just one controller and 2 computes. In this particular case, now the operator has picked which one of these is going to be the controller, either by flavor matching or by tagging the machine. All right? The operator has also picked now the 2 compute resource nodes. With everything set up, you run the deployment. What happens here is we write the overcloud full image, that's your operating system and all of the OpenStack packages and all of the Puppet modules, which are going to be run. You write each of that to the root volume on each machine, reboot the machines into the full image, write the network config files, IP, all of the IP config files for each network interface using OSNet config, bring up all of those interfaces. Once they're all up, ping all of the addresses that are supposed to be available. It turns out usually they're not available, and you wind up having to stop here, call your switch guy and say, hey, where's my VLAN that you said you were going to configure? And he said, oh, I forgot, I had to go get some coffee. Anyway, so you stop here, fix your switches, and then come back and run it again. And once the networks all do actually ping correctly, then you start running Puppet on all of the nodes. In the current TripleO heat templates, we split the Puppet run into 7 steps so that we can order how the services come up. You need to configure the database first, then you can configure the message bus, and you can do various other things, and finally, you bring up Pacemaker, in our case, and finish off the deployment. And we're done. OpenStack, voila. Once the deployment is complete, we can scale out should we need to. We can add more computes, we can add more storage, and so on. questions on any of that so far? I feel like I'm going relatively fast, but I don't want to go so fast that you guys are missing important information. If you do have questions, just yell, and I will try to answer them. I probably can't see if you're raising your hand at this point. Yes?
Maybe it's going to be a simple one. It's not so simple. Why do we need to separate OpenStack between this whole? Do you think it would be the first one? I mean, the one and only OpenStack.
Well, I'm tempted to refer back to the first slide. Where did the first No, it's okay. Where did the first OpenStack come from? Right. Using what? I mean, that's the point. You have to start with an OpenStack, and what we're doing is using an OpenStack to deploy another OpenStack, right? I might have misunderstood your question, though.
I mean, the scaling and building everything you need.
Yeah. Okay.
I don't see the point of the two layers of OpenStack, all top and under OpenStack.
Ah, I see.
So in other solutions like VMware and so on, they can, as far as I see in your presentation, they can do this on a single layer.
Right. So here's the thing. The thing that we found interesting about the project was the idea of using the OpenStack services to install OpenStack. You have to have some kind of an installer, right? Mirantis has Fuel, it runs on a separate machine. VMware has a VMware installer, it runs and then exits, right? The undercloud, in this case, is an OpenStack instance that we set up so that we can deploy a much larger OpenStack instance. It hangs around and provides monitoring and scale out and the other things that an OpenStack instance would provide to its tenants, right? So that's kind of the point. Does that make sense at all? Okay.
So as far as I understood, this is like Fuel, but it's a small OpenStack environment, and it just takes care about deployment and managing running big OpenStack environment.
That's exactly right. If you guys didn't hear, the gentleman said this is like Fuel, but it's actually a little OpenStack that takes care of the big OpenStack, and that's precisely what it is. We share a lot of components with Fuel, particularly the Puppet modules. Mirantis, both Redhat and Mirantis are major contributors to that. The Puppet pacemaker module, a bunch of other things like that.
Why do you use Puppet? Why don't you use Ansible instead of Puppet?
Why don't we use Ansible instead of Puppet, the man says. Very good question. But actually, I have a good answer to that one. The reason that we use Puppet, well, there's two reasons, really. The first reason is we've been doing this for 2 years plus. And when we started, the OpenStack Puppet modules was the way to configure OpenStack. The second reason we continue to use Puppet is that as of right now, the OpenStack Puppet modules are still the way to configure OpenStack. And it's not broken, right?
Do you plan to go away from Puppet and target Ansible?
It is very possible that we will do something different. The big question that we're wrestling with now, and it's a tough one, is do we go straight to Kubernetes, right? Or do we go to Ansible and Kubernetes or something else? All of these things are very much in play, and we're not sure what the right answer is going to be yet. It kind of depends on where upstream goes on. If we got to a point where there's a single Ansible community that's very strong on config, instead of right now there's 3 or 4 of them that sort of compete, then especially given the fact that we acquired Ansible, we're going to have a hard time not switching. But if we can go straight to Kubernetes, then I feel like we'd be wasting some amount of effort, you know. So these are the things that the TripleO upstream is arguing about. Other questions before I move on? Okay, cool. I'm going to talk now about what we currently support. And these are, just to be clear, these are all features that you can try out and use yourself if you install RDO Liberty or even RDO Mitaka, which should be all working. And if you happen to be a Red Hat partner or subscriber, you can try them out in the OSP Director product. But you will find that the product features are very close to the upstream features. Right, so what do we do right now? As of Kilo TripleO, we have a full set of APIs for deployment and management. This is nice because it means we can integrate with third-party tools. ManageIQ, for example, OpenShift is another good example. People who want to hit the TripleO APIs in order to manage a cloud themselves, we provide those APIs. This is why we want to have that undercloud hanging around, because we need something to continue providing those APIs over time. We have full CLI, which is the OpenStack CLI. We do, I mentioned this a little bit earlier, but when we're bringing up fresh hardware, we do a lot of configuration on the machines before we actually install the software. So we can set up RAID arrays on Dell machines in advance of the deployment. We can do some amount of BIOS updating and things like that. And we do all of the network configuration, which is pretty nice, actually. We automatically pick the node that you want for a particular role from the inventory that's in the Ironic DB, either, like I said, by flavor matching or by tagging. We can automatically validate your install with Tempest post-deploy. Out of the box, we do a full 3-controller HA setup with Pacemaker. That has some nice advantages because of the Pacemaker resource agents for things like Galera and Rabbit and the Neutron agents and those other services that have a complicated bring-up process. Pacemaker is really good at doing that, so we hand that job over to Pacemaker. And finally, we have the ability to scale compute and storage resources up and down. Let's see. Storage features, we can do a limited but complete Ceph deployment. We don't cover nearly all of the permutations, but we can do a working one out of the box. Or we can configure everything to hook up to a separate Ceph deployment that you may already have. We can connect to an external hardware load balancer. We integrate with a number of the different vendor power management interfaces, DRAC, ILO, AMT, upstream, a couple of others, and of course always, generic IPMI. Although I will tell you that the IPMI controllers on these computers are garbage. My God, they're just terrible. Anyway, that's a story of another rant. We have also upstream, we have SDN integration with partners like Communicura, Nuage, Big Switch, Juniper Contrail. I'm forgetting one, I know. Anyway, we've had pretty good support from those folks for SDN integration. In Liberty, we brought out support for automatic updates and upgrades. What that means for minor updates, we can apply minor releases or config changes to the whole cluster with no downtime, and do it in an organized way. This is important because given that we're running Puppet on everything, if you're using a TripleO deployment and you go manually tweak a config file on one of your machines, the next time you do a stack update, Puppet's going to run and Puppet will happily erase your customization. So we have to make sure that we can provide that ability to modify, config, or do minor updates at any time. And we do that. For major upgrades, we introduced this with Liberty. We can programmatically upgrade the entire cloud from Kilo to Liberty. There is always some amount of downtime there because we have to take the control plane down, but your guests will keep running until you get to the point where you need to actually reboot your compute nodes. And I think you all, if you're OpenStack operators, you know that what you do is you migrate the guests off and then you reboot the node into the new kernel and then migrate them back on. So that was a pretty big deal. It's a multi-step process to do it, but it does work. Yes, back here?
During the upgrade, do you upgrade the undercloud as well from Kilo to Liberty?
Yes, that's the first step, actually, and it's important to note that the Liberty undercloud supports both Kilo and Liberty templates. So we have, one of the tricky things you get into is that for each new version of OpenStack, you have updated Puppet modules and updated templates that go with that version. However, Heat and the rest of the TripleO stack are capable of operating on at least one prior version of the templates and Puppet modules. So you could install the Liberty TripleO and a Liberty undercloud and use it to install a Kilo overcloud, which we test that, and then upgrade it to Liberty if you needed to, which you presumably would want to do that, but anyway. Yes. It is important to note that there's some control plane downtime involved in that, and there is also a moment when the L3 agents go offline, so your guests lose connectivity until we've upgraded the L3 agent to the new version. If you had DVR, you wouldn't have that, but anyway. IPv6. We added IPv6 support actually after Kilo was already EOL'd. We added it to Kilo anyway. Right, so we have IPv6 in Kilo and Liberty for all of the externally facing networks and the internal API network. We didn't do the storage network because, surprise, storage networks, most storage arrays don't support IPv6. Here we are in 2016. So we decided not to bother with that. But we do have full IPv6 config support. It was not easy, but it is there. We are coming, hopefully, in the next cycle with dual stack support so that at least some of the networks you'll be able to pick both IPv4 and IPv6 ranges. And as far as I know, we're the only deployment tool that does this at the moment. We also have TLS support all over the place. TLS support for all the public API networks. That includes single or dual PKI. It includes the various different certificate signing mechanisms, and we terminated with HA proxy in front. We do not yet have TLS support on the internal API networks. That should be coming in the next release. It's harder to do that, and it kind of requires some kind of a certificate server. In our case, we'll probably wind up using whatever the cert server is, dogtag, that ships with free IPA. Let's see, so that's TLS. Oh yes, for fun in Liberty, we also have a containerized compute node, which is funny because why would you want a containerized compute node? But we did it because we wanted to prove that we could, basically. On that containerized compute node, we have the Nova API, libvirt, and I forget the other thing, running in 3 separate containers. The guests, of course, run native on the host. But if you want to play around with doing containerized deployment, that's a good way to do it. Now, my favorite part, the stuff we're adding for Newton. There's lots of fun stuff in here. Any questions before I move on? I think I got a few more minutes yet. Okay, cool.
I have a
Yes.
Actually, what I like in Vue is that Vue is very modular. You can write plugins if you want to add extra applications. Does this product also bring this modularity like in Vue? I mean, can I write a plugin to integrate OpenDay like SDN control?
The question was, do we have Fuel-like plugins? In other words, can I write a plugin to add an additional service? Fortunately, that is one of the things that is on this slide that I'm about to show you right now. Little bit of history, and then I'm glad you asked this question. A little bit of history. We had, when we rolled out the first set of TripleO heat templates, we, for reasons of getting it out the door, wound up with a single monolithic, basically a single giant monolithic template. And it was difficult to add individual pieces to those templates. Quite difficult. We are now actually in the process for Newton of modularizing all of those templates. So in the new model, we're calling this composable service roles and composable roles. In this model, you'll be able to, for a given role, let's say you've got a controller role or a compute role or a network role or whatever, for a given role, you'll be able to specify, okay, I want these 4 services deployed on this role. And if one of those services is a template that you brought yourself with some Puppet modules that you brought yourself, that's fine. And it should just work. So this is, the ability to do that is upstream now in TripleO. We're in the process of converting all of the services over to the new model. And it should make it much easier to add stuff to TripleO. Yeah, before, like our SDN partners, they had to get patches into TripleO upstream to support the SDN configuration that they needed. With composable services, that wouldn't be necessary anymore. Other questions? No. Okay. Cool. Let's see. So that's composable roles. Split stack is another interesting piece. It turns out that TripleO is pretty good at doing just the hardware provisioning part of the thing, of a deployment, or just the software config part of a deployment, if that's what you want. We call this split stack, and that means that you could do, if you wanted to do a full deployment up through the network config and then stop and use, say, Ansible and Puppet to do the other half, you could do that. The only drawback is that it would not integrate with the TripleO UI. You wouldn't be able to use TripleO UI, but you could still do your deployment that way if you wanted to. Alternatively, if you are like some of our customers and you've already got a set of machines that are provisioned, racked, wired, and configured the way you want, you could then use only the software part of TripleO to deploy and configure the services on the machines without having to mess around with, to use Ironic or do any of the hardware provisioning part. So we hope that this will make a lot of user situations easier, working around the different things that we actually run into when we're doing deployments on site. Let's see, what else? One more thing here. Oh, yes. Yes, my favorite part. The new TripleO UI is coming. I hope it will all land in Newton, but it's available now if you don't mind downloading stuff from a GitHub repo. This is a really neat thing. It's a React.js UI. It's pure JavaScript, entirely stateless. It runs in your browser and connects back to the undercloud APIs for all of its operations. The neat thing is we've introduced Mistral as a way to manage the workflows of these deployments. So Mistral talking to Heat, basically. The UI is now aware of Mistral and can monitor the workflows that it's doing. And because the UI can now subscribe to a Zakar queue, we get an automatic sort of immediate response back from the undercloud when the UI does something outside of the HTTP request response flow. So the Zakar basically gives you an automatic kind of long-running pipe to the server, which means that when you make an action in the UI, you get an immediate response, no matter what it is. We have folks in our field at Red Hat using the UI now. It's not complete yet, so it's definitely still a little sketchy, but we're having them go out there and do POCs with it so we know it works when it turns up. The other cool thing about the UI is that the heat templates give you basically a whole parameter schema. Like when you write the templates tell you what the services require in order to configure them. You do that just by a heat stack, I can't remember the command. Anyway, the heat stack introspect or something, and it pulls back all of these parameters. And the UI picks them up and says, okay, here's the parameters you need, and puts them in a form for you. So if you add a new parameter, you don't have to add any new UI code, it just shows up in the UI, which is kind of neat. So that's what we see turning up for Newton, plus some hopefully interesting HA simplifications, we think. But I'm not going to talk too much about that because I'm not sure when it's going to land. In Okata, we are very, very interested in adding support for multiple overclouds. In other words, we want TripleO to be able to deploy 10 or 20 or 100 OpenStacks rather than just one OpenStack. There's various reasons you would want to do that. The one I always thought was interesting is to have a staging cloud and prod cloud managed from the same undercloud. But there's also other reasons you would want to do it. High availability for the undercloud goes along with that. We want to add, I don't think, we're not going to get this for Newton, but I would love to see in Okata, I would love to see a fully containerized overcloud. I mentioned we're not sure how we're going to do this yet. Kubernetes would be a nice choice, but I think we'll probably start with the simplest thing we can possibly do and just do a Docker run everywhere we want to bring a container up. And we may use elements of the Cola containers to do that. That's not totally clear to me yet. Finally, we will be working on single and multi-tenant Ironic in the overcloud support. We, even though we use Ironic all over the place, we don't actually deploy it correctly in Mitaka. So I hope we get that, if not for Newton, certainly for Okata. And that means that we are out of time. So I will just put these up here. If you want to get involved or you're interested in trying it out or kicking the tires, TripleO.org is the most obvious place to look, where you will find, in all his glory, Trippy, the TripleO owl. Owls all the way down. We have, on the RDO site, we've got documentation for the TripleO Quick Start. You should be able to get OpenStack up and running in 30 minutes with a Quick Start, assuming you have a machine with enough memory. And mailing lists and also IRC are up here. Again, I'm Hugh Brock. Thank you very much for your time. If you have any questions, hit me after the thing here. Thank you very much.